Hi everyone. We are on our new unit, function operations. Before we get into the specifics of this unit, we need to do a quick review of functions, mainly the types of functions. So let's just go through the list of them. First, we have polynomial functions. A polynomial function in X is a function of the form, okay, where all the a values are real numbers and a does not equal 0, and n is an element of a whole number. The a's are called coefficients. The first a right here, this is the leading coefficient, and a0 is the constant term, so this is like a number. The value of n is the degree of the polynomial, so here's that exponent. This will tell you the degree. Okay. For example, the polynomial function f of x equals 7x cubed plus x to the fourth minus 8x squared plus 5 has a degree of, so we look at the highest exponent. So look at the term with the highest exponent, and that's 4, so it's a degree of 4. And then x to the fourth, what's the coefficient in front of the highest degree term? That's the lead coefficient, so it's 1. And the constant term, the one without a variable, is 5. You will see common polynomial functions, and we'll use these functions pretty much throughout a lot of our units in this course. Linear functions, quadratic functions, and cubic functions. So let's step through these and more, the different types of functions. First one, linear functions. A linear function is a polynomial function of degree 1 of the form. We know this from Math 10c. F of x equals ax plus b. So we kind of remember this format, right? Y equals mx plus b, where that's your y-intercept, and this is your slope. Now the function whose graph is a straight line is a constant function, a function whose value never changes. It is a polynomial function of degree 0 and can be written in the form f of x equals a times x to the 0, or just f of x equals a. This would be a horizontal line. All right, let's sketch a couple of these examples here. Sketch each of the following. Number 1, y equals 3x plus 1. So b equals 1, that would be a y-intercept, so roughly there. And when y equals 0, you're going to get x equals negative 1/3. So 0 equals 3x plus 1. Negative 1 equals 3x. Negative 1/3 equals x. So your x-intercept is negative 1/3. So the line is going to look like this, and that's a positive slope. Remember, rising when you're going from left to right. Okay, domain and range using. Okay, state the domain and range. The domain using set builder notation, so not interval notation. Domain x such that x is an element of all real numbers. And then y such that y is an element of real numbers. Okay, and then let's do this in set builder notation as well. That's negative infinity to positive infinity. That's negative infinity to positive infinity. Okay. Next one. This is a horizontal line, so y equals 5, so the y-intercept is 5. Okay, state the domain, interval notation, x such that x is an element of all reals. Okay. sorry, using set build. This is set builder notation. So this is set builder notation. Okay, and then for the range, y such that y, the range doesn't vary from 5, so just y equals 5. Okay, or interval notation. Okay, 5. All right, next page. Quadratic functions. Quadratic function is a polynomial function of degree 2, which can be written in general or standard form. This is what we did all of Math 20-1, is we talked a lot about, we use quadratic functions, okay? General form, f of x equals ax squared plus bx plus c, where a does not equal 0. Standard form, this is your vertex form, also vertex form. Okay, oops, that should be a v, vertex form. A times x minus b squared plus q, where a does not equal 0, using a graphing calculator. Where are we? Right here. Use a graphing calculator to sketch the graph of the function with equation y equals x squared minus 3x minus 18. Okay, so if you want to pause the video here and graph this and then try to answer some of these. Okay. All right, so the zeros of the function, so x equals 6 and negative 3. Y-intercept of the graph is 0, negative 18. The coordinates of the vertex, 1.5 and negative 20.25. Okay, let's sketch this. So I have negative 3 and I have 6. Negative 18 is my y-intercept, and then my vertex is somewhere over here. A little bit more accurate here. Okay, that's my vertex. So it's an upward opening parabola. Okay, the domain and range, x. So domain is x such that x is an element of all real numbers, or in interval notation, there it is, range y such that y is, well, greater than or equal to a negative 20.25, and that's the y coordinate of my vertex, right? So negative 20.25, y is an element of all real numbers, or in interval notation, it starts at negative 20.25 and it stretches to infinity. So that's how we do it in interval notation. Use factoring to determine the zeros. Okay, so if I'm factoring that, 0 equals x minus 6, x plus 3. Okay, and that's x equals 6, x equals negative 3. So that's what we saw for the zeros of the function. This I got from my calculator. C. Rewrite the equation of the graph of the quadratic in standard form. Explain how this form helps determine the vertex of the graph. Okay, so this is your completing the square. So okay, remember we separate the first two terms, then we divide that 3, negative 3 divided by 2, and then we square it. So that is plus 9/4. Oops, minus 3x plus 9/4. And then we subtract 9/4 minus 18. And then we want to kick out this negative 9/4. So it's minus 18 minus 9/4. Okay, perfect square trinomial. Let's factor it. And then this is 72/4 minus 9/4. Okay, y equals x minus, let me make them in the decimals so we can match it to what we got from our calculator. X minus 1.5 squared minus 81/4, which is also 20.25. And this matches our form y equals a times x minus p squared plus k, oops, not k, plus q. And then our vertex, where's our vertex? There's our vertex. And here's the coordinates of our vertex. So p equals 1.5, q equals negative 20.25. All right. Next one, cubic function. A cubic function is a polynomial function of degree 3 of the form f of x equals ax cubed plus bx squared plus cx plus d, where a does not equal 0. Consider the cubic function y equals x cubed minus 8x squared plus 16x minus 8. Use a graphing calculator to sketch the graph of the cubic function. Use the features of a graphing calculator to determine the x-intercepts of the graph to the nearest tenth. Okay, so first off, I get, here's a basic sketch of what it, oops, doesn't quite go through the 0 here. Okay, something like that. 0.8, 2, and 5.2. Okay, absolute value function. An absolute value function is a function of the form f of x equals absolute value of x, where f of x equals absolute value of x. Remember, we have cases, case 1 and case 2. Right? Remember solving these equations and thinking about absolute values. There's always a positive case and a negative case. Sketch the graph of the absolute value function f of x equals absolute value of x minus 2 and determine the domain and range. So when we sketch this, it'll have a vertex at 2, and then it will look like a big V. Okay, domain. Let me do it in set builder notation. X such that x is an element of all reals, or in interval notation, negative infinity, positive infinity, and then the range. It's going to start at the vertex at 2, so x is great. Oops. Y is greater than or equal to 2, and y is an element of all real numbers, or 2 to infinity. Okay, radical functions, another type of function that we will see in this course. Radical function is a function which contains a variable in the radicand. Remember, radicand is what's underneath the radical sign, such as f of x equals square root of x. Sketch the radical function g of x equals square root of 2x minus 1. So it starts at 1, okay, and it does this characteristic thing, almost the sideways half parabola, okay? Determine the domain and range of the function. So domain x such that, well, let's see, x is going to be greater than or equal to 1. Oops. Sorry, x is going to be greater than or equal to sorry, this should be 1/2. Sorry about that, folks. So if x is 1/2, that makes g of x equal to 0. So 1/2 is 0. So sorry about that. X is greater than or equal to 1/2. X is an element of all reals. Okay, so everything to the right of 1/2, or 1/2 infinity. Range. Okay, also, let's see, it's going to start from the 0. So y such that y is greater than or equal to 0. Or 0 positive infinity. Okay, let's do a little bit on function notation because we will actually do a lot of this kind of thing in the next couple lessons in this unit. If f of x equals x squared plus 4x plus 5, find the following in simplest form. So f of 2. So when it's f of x, we insert x's wherever the x's are in the function. So when we see f of 2, we insert a 2. So 2 squared plus 4 times 2 plus 5, and then evaluate. 4 plus 8 plus 5. So 4 and 8 is 12, and 5 is 17. Okay, 2f of x. Well, this time we're multiplying the function, entire function, by 2. So 2f of x equals 2 times x squared plus 4x plus 5, and that equals 2x squared plus 8x plus 10. Okay, f of 2x, so wherever you see the x value, I'm going to insert a 2x. So f of 2x equals, so 2x squared plus 4 times 2x plus 5. That's 4x squared plus 8x plus 5. Okay, next one, f of x minus 2. So we literally take the function f of x. So f of x minus 2 equals, we take x squared plus 4x plus 5. That's the original function. And then we subtract 2 from it. And what do we get? We get x squared plus 4x plus 3. Okay, f of x minus 2. So we take f of x minus 2. We take the x minus 2 when we insert it everywhere x is. So x minus 2 squared plus 4 times x minus 2 plus 5. And let's expand and simplify. X squared minus 4x plus 4 plus 4x minus 8 plus 5. That is x squared minus 4x plus 4x is 0. And then 4 and negative 8 is negative 4, and 5 is plus 1. And the last one, f of negative x. So wherever there's an x, we're going to insert negative x. So negative x squared plus 4 times negative x plus 5. That equals x squared minus 4x plus 5. Examples, let's see. Consider the following. Consider the function f of x equals x cubed, so a cubic. So let's name this. This is a cubic. Match each function on the right with an expression on the left. Okay, so f of x plus 5, that is x plus 5 cubed. So b with 1. Okay, f of 5x, so I'm going to put 5x wherever the x cubed is, so 5x cubed. And there it is, 2 is D. F of x plus 5, so I'm going to take x cubed, and I'm just going to add 5 to it. Which one is that one? That one right there. Okay, and then f of 5, so I'm just going to take 5, put it wherever the x is, and then execute the function. And there we go. Okay, last one. If f of x equals absolute value of x, write the following in terms of the function f. So what this means is wherever I see the square root of x, wherever I see the absolute value of x, I'm going to um, rewrite it in terms of the function f. So if I have a absolute value of x minus 4, that is f of x minus 4. Okay, this one, everything's entirely in the absolute value bracket, so this is like saying f of x minus 4. So I've taken x minus 4 and I insert it into the function wherever the x is, and that's the result. So f of x minus 4. So it's kind of like working backwards. 2 times absolute value of x. Well, this is just 2 times f of x. So this would be your function f of x, and then we're just multiplying by 2. 2x, absolute value of 2x, last one, letter D. This is like saying f of 2x. So if we take 2x and we substitute it into where we see an absolute value or where we see the x, we get f of 2x.